No, you just created a backdoor. You just created a vulnerability in your system. If you're a front-end developer, at least one time in your life, you have faced this problem. And if you're a back-end developer, at least one time in your life, you confused with this problem. This is that much common. This is that much powerful. So there's some concept called CORS, cross-origin resource sharing. This concept is very, very simple if you really get to know this. But this is so much powerful. Well-experienced software engineers also getting confused with this. So today, I'm going to explain this so powerful yet simple but hugely confused topic in a very simple plain English, right? So get ready. So before that, if you're not subscribed yet, please go ahead and subscribe. And why? Because there's so many complicated topics we discuss here in very simple terms and in very simple way. And also, we are discussing here very practical, industry standard examples with demonstration. So this is something you must subscribe. And also, click the thumbs up if you like these videos. Anyway, so just think like this. Before we go into there, just think something like this. Let's assume there is a fly over a certain country on a certain path and a certain altitudes. Let's say 33,000 altitudes. This flight A is flying. This flight B is flying in the opposite direction, in the same route, in the same altitude. What's going to happen? It's going to collide. We call this a mid-air collision, right? This is a very dangerous and this is a very disastrous because all the passengers in these flights is going to die. So therefore, what they do is, these things happen in history, right? Because when you go in like this, so this guy is thinking, oh, I need to climb because this guy is coming, and this person is also thinking, I'm going to climb because this guy is coming, and both is make the same decision, and then again they're going to collide. Why they make the same decision? Because they're human, right? And they're human, they think in the same way. So both may decide either climb or either descend, so they're going to collide. So as a result, what they do is now, before you enter the country, they make something called pre-flight call. Pre-flight request, right? So then the ground is going to decide what altitude and what route they're flying. Not the route actually, what altitude they're flying. So problem is kind of solved. We use this in our software industry. So before we dig deep in this topic, let me to bring a small smile to your face. Okay, when I tell the story, I'm sure you're going to smile. Okay, so this is how it works. Let's say you create a backend API and it worked well for you and you gave it to the front-end developer. And he said, this doesn't work. Then you are saying, no, it worked for me. He says, no, it doesn't work for me. When you go and check, yeah, it doesn't work in the browser. It says cause error. It worked on your REST client like a Postman. It doesn't work on the browser. So now you Google it and you landing on the Stack Overflow and some guy says, hey, go and enable the cause. What do? You come to your code and see enable cause or a cause annotation, whatever, depending on your language, and you enable cause with a wildcard asterisk character. And then you see it worked. And now you are so happy you fixed the problem. No, you just created a backdoor. You just created a vulnerability in your system. You should never do this on a production system. It's okay you do this in a dev environment, but don't ever do this on the production. Then what is this? Okay, let's go and see why exactly cause is important and why it is only causing on the browser but not on our REST client. So this is how it works, right? So when you have the cause or a cause origin resource sharing is a web origin concept. Okay, so I'm not going to read this content. You can pause the video and read this, but I'm going to explain it how this works. Okay, so let's say you have a web server called codelabs.lk, and then you have other web server called cosmos.codelabs.lk. Right, one is a codelabs.lk and another one is a subdomain called cosmos.codelabs.lk. So now in your web document, you are going to refer an image from image1.png from the codelabs.lk. And also you are referring image2.png from cosmos.codelabs.lk. right? So now you are referring two different images from two different domains. See, now you can see here your web page hosted on codeslab.lk. So therefore, this part, this image 2 is going through something called course management, right? Or a course policy, right? So let's see what is this. So let's see why we need course. When you think about the web environment, from your browser, you make bunch of calls to your server. Maybe you want to get an image, maybe your icon, maybe your fonts, maybe your scripts, maybe your content. Doesn't matter what, you are asking so many resources from the server. Meantime, you creating resource on the server also, right? So you creating employee record, you may creating a document record, you may do various things. So that means you may read resource, you may create resource, maybe you delete resource, or maybe you update resource. If you let this go unchecked, if you do this without checking, then your content become vulnerable. Why? Because anyone can get your content as well as anyone can update or read your content. Now you can think, no, we use access token, right? No, we are not talking about that. Okay, let's see why. So for example, let's say as our previous example, this web server codeslab.lk hosting image1.png, and some page from codeslab.lk trying to read a image from the cosmos.codeslab.lk, right? In this case, at least domain same. You can think it's the same person. Let's say codeslab.lk trying to read an image from krish.lk. In that case, you can understand this is completely two different domain. It is not in a same domain or a same server at all, right? So now when you come to krish.com, krish.lk, you don't want to waste your bandwidth giving your resource to outside, right? Because, it's your bandwidth. Let's say something like that, krish.lk, a.lk, b.com, c.com, d.com, like 1,000 website is trying to grab your resource. Then it consumes your bandwidth. You don't want to do this. So one way you can control this is a same origin policy. Same origin policy mean you only allow the content, the request from your domain to consume your resources. In that case, this index.html or whatever this page, if it is hosted on codeslab.lk, they can only get content from the codeslab.lk, right? In order to access this image2.png from the cosmos.codeslab.lk or a krish.lk or a abc.com or whatever, you need to host this index file also in the same server. That's called same origin policy. Which means if you have a company which has multiple of subdomains, you need to copy your content with each subdomain, right? Because let's say you have a logo, you need to copy logo for each domain, right? Each server. And if you have some script, you need to copy that script for each server. If you have 10 servers, which are 10 different subdomains, you need to copy this content everywhere, right? This is a waste. And also it's hard to maintain. If you want to change something to the script, you need to update 10 different places. If you want to change the image, you need to update 10 different places. That is not feasible at all. So therefore, same origin policy is not a very good one. So now the question is how they decide whether this is same origin or not. They consider three things. It's very simple. One is a protocol, which means HTTP or HTTPS. Second one is a domain name, which say abc.com, cde.com, codeslab.lk or subdomain.codeslab.lk, right? So let's say sales.codeslab.lk is a different from finance.codeslab.lk. It's like that, right? Complete host name. And then also the port. For example, something run on port 8080 is a different origin than something run on port 8081, right? Ports also considered as the same origin. So if these three things equal, we consider as the same origin. If one of these, at least one of these change, and then we consider as a different origin, which is go under the cross origin. For example, in the given example, you can see codelabs.lk index.html, HTTP codeslab.lk product.html is allowed. It considers the same origin policy. But http.cosmos.codelabs.lk features.html is not allowed. Why? Because the host name different, right? Protocol same, port 88 is not there, but the host name is different. So therefore, it's considered as a different origin. So now, why cause is necessary? I explained this little bit before, because you want to make sure someone unauthorized is not accessing your resource in any manner. It may be read, update or delete, it doesn't matter. So now one side is the same origin policy. We see it's a very restrictive, right? You need to copy over your content to everywhere. Other one is a fully open. But when you see it's a fully open way, you can say read is fine because it's fine. I don't care about the bandwidth. But the problem is they're getting access to write and update your resource as well. Also delete your resources, right? So that is very dangerous, right? So if you want to understand this like detail, just stop, pause the video and read this content, okay? But I'm not going to waste time over there. Now the problem is, this is frustrating cause problem. What we experience in daily basis, how it cause. Cause validation happen in 3 different ways, right? It consider whether you are coming from the real origin which is allowed, whether you are carrying allowed headers and you are doing something what you're allowed to do, which means it's checking your origin and it's checking your headers and it's checking your method, whether it's a get or post or put or whatever, right? The real flight example, what we discussed before the flight enter and it's saying, hey, I'm origin from Sri Lanka or I'm origin from United States and I'm carrying this much of passengers and can I fly over your country? I don't know, this is the exact messages they are passing, what I'm saying, just hypothetically. So likewise, we send the pre-flight request to the server, okay? Now, let's go with a real example. So you have a browser which trying to create an employee record. And your server hosted the API called api.codeslab.lk/employee. Okay, HTTPS protocol run on a port 443 because it's HTTPS run on a port 443. Okay, so now your application run on a domain called app.codeslab.lk. You are trying to hit api.codeslab.lk, right? Now you can say it's going to deal with the cause or a cross origin. Why? Because the domain name different. Okay, cool. So now we are trying to send the GET request api.codeslab.lk/employees. That's the endpoint. Okay. So now it's a cross origin. Why? Because domain different. Before this dispatch, when you run this in a Postman or Insomnia, it's going to work. Any REST client or a curl command is going to work. This only experience in a browser. Keep in mind, this only experience within the browser. Right? So now before you dispatch this request, your browser, it sends a pre-flight request to the server. And it's asking, hey, I'm origin from app.codeslab.lk. This is my origin. I'm going to send a GET call. I'm carrying authorization header, content type headers. Can I come in? Then the server, your server is responding. If your server is course enable, right? The type of this request is an option. If you say the get or post or put like that, the request type, the verb is an option. Now, if your API is course enable, it replying back saying, I am allowing these origins, I am allowing these methods, and I am allowing these headers. So now browser see, okay, he's allowing this, I am going to send this, can I go? And if it is allowed, you go. Here's the problem cause. If you are not enable course, then your server, your API will not respond to the pre-flight request. Okay? If it is not responding to the pre-flight request, then your browser show error saying course failed. That is the way your front-end developer come and reach you saying, hey, this is not working. Okay? You are saying this is working because you tried on a Postman. It worked Postman because Postman do not send pre-flight calls. Okay? So now we got the problem. Why the problem? Cause not enable. So how you do correctly? How you enable correctly cause? If you need to enable cause correctly, do not ever put an asterisk. Asterisk means you are allowing any origin to come. You are allowing any method to execute. You are allowing any headers. Okay? When you're not specifying, you blindly enable asterisk. You open your API, you open your resource to globally. Anyone can do anything. Okay? So don't do that. So how you correctly enable the CORS? You are saying allowed origin is app.codeslab.lk. That origin is allowed. HTTPS app.codeslab.lk. That origin is allowed. And then you are saying I'm allowing get and post, but I'm not allowing put and delete, right? Allowed methods get and post. Allowed headers, I'm allowing authorization header and content type header. Okay, let's say something like this. If it is a get call, you don't need to send the content type, but since it's a post call allowing, you are allowing the content type header as well. So now you do this from your service, right? I mean, I can't show how to do it because it's different language to language and framework to framework. But since we are trying to do the serverless some APIs, then I'm going to demonstrate that how to do it in a serverless way, right? But for now, you just see how to do that in your Spring Boot or a Node.js or Express way, okay? Now, you're saying done. Now, again, when you try to execute from the browser, it gives the error saying this header is not present or something. CORS failed, header is not present. That means you allowed two headers. They are trying to send some third header to your call. That case also CORS failed. Okay? CORS fails two cases. One, you are not enable the CORS at all from your services. The second, you enable the CORS, but they are either coming from a different origin, either they are coming from, how you calculate the origin? Protocol, domain name, and the port, right? Either you enable HTTP app.codeslab.lk, and they are coming from HTTPS app.codeslab.lk. Looks like they are same, apps.codeslab.lk, apps.codeslab.lk, but the protocol different. That means origin violated. Okay? Maybe you're allowed port 80, they're coming from port 443, which is HTTPS. Different, right? Remember, we discussed how the origin calculated. There has to be exact same origin. If the origin same, you allow get and post, maybe they are trying to put, or maybe they are trying to delete. That case also CORS fail. Both are correct. Now you allow two headers, they may be sending a third header. In that case, CORS fail. Okay, so now how you should fix this? You need to exactly see the problem and fix that, right? So you can use, if your APIs are publicly open, you can use a testcourse.org website, and then you can set up your call and you can see whether really CORS is working. So then you can isolate the problem, right? So this is a real traffic going through, right? So you can see, this is trying to go for server asking /doc is the endpoint, get is the type, right? Origin is serverb.com, okay? Serverb.com is the origin. So now you can see here, this is a normal request. So now you can see here pre-flight request, right? It's sending an option call to the doc endpoint, right? It say origin equal http:/foo.example.com example, okay? So now you can see the origin properly. And access control request method. I am requesting post call. Access control request headers. I am requesting these two headers. So now the server responding back saying to the option call, right? We didn't send the get call yet, right? Hey, say access control allow origin, right? And it says I am only allowed to http foo.example domain. So that means it's allowed, right? And access control allow methods. I am allowing post, get, and options. Keep in mind, when the server responding, server doesn't respond to the particular call. Server responding what it can do, and then the browser make the decision whether it should go or not. That's why you sometimes use a browser interceptors to bypass this validation, right? You should not do that, but sometimes people do it. And then it says access control allow headers, right? So you can say these two headers is whitelisted. So it's good to go, right? Remember again, when the client sending, client says access control request method. I am requesting this method. I am requesting these headers, right? The server responding, I am allowed, right? Server say access control allow origin, access control allow headers. Client says, access control request headers. Server says access control allow headers. These two should overlap in order to this work. Okay, so I hope you understand now. From here onwards, when you get this cause error, don't get panic. Read the message, what it says, whether it says origin violated, whether it says header violated, or whether it says method violated. Then fix exact your problem from your server. Do not ever enable wildcard cause because you're creating a backdoor. Then I hope you understand this complicated, confusing topic in simple way. So subscribe if you're not subscribed yet, like if you didn't like, and ask any question if you have. Then we'll see you soon in another video. Stay safe, take care.